Welcome to Math Superville. Today we're going to discuss the concept of distance, rate, and time. So the objectives are to use formulas to calculate speed, distance, or time. The next one is to solve problems involving amount of work done, rate of work done, and time. So the main formula is rate times time is equal to distance. So rate times time is equal to distance. So this is the way we denote the formula. So for example, what distance would you travel in 10 hours at 70 miles per hour? Let's call this example 0. So the solution to this is as follows. Recall that distance is equal to the rate times time. What are we given? We're given the rate is 70 miles per hour, and we're given the time to be 10 hours. So if we apply the formula, we just plug in the quantities given. So 70 miles per hour times 10 hours. And so this gives us the distance to be 700 miles. So moving at the speed of 70 miles per hour for 10 hours means you cover a distance of 700 miles. The next one says, in Kerio River, a boat can travel 10 kilometers upstream against current in the same time that it travels 35 kilometers downstream with the current. If the current flows at a rate of 3 kilometers per hour, find the speed of the boat with no current. So remember, the distance to travel downstream is 35 kilometers. And the distance to travel upstream is 10 kilometers. Additionally, we're given that the rate, before I discuss the rate for downstream, I'm going to denote that x is equal to the rate of the boat in still water or without current. So traveling downstream, the rate of the boat should be the rate of the boat plus the current speed, which is 3. So that's why the boat ends up traveling a longer distance downstream. Upstream should be x minus 3 kilometers per hour. So the time it takes to travel downstream, we will call this T1. And remember, the time is given as distance divided by the rate. So this is 35 divided by x plus 3. To go upstream, the time should be 10 kilometers divided by x minus 3. So this is the time. We will call the first part, where we are identifying the variables, our first step. The second step is where we fill in the table. The third step is to acknowledge that in the problem, we are told that the time it takes the boat to go a distance of 10 kilometers upstream is the same as the time it takes the boat to travel 35 kilometers downstream. In other words, T1 is equal to T2, which means 35 divided by x plus 3 is equal to 10 divided by x minus 3. And when we cross multiply, we end up with 10 times x plus 3 is equal to 35 times x minus 3. So this gives us 10x plus 30 is equal to 35x minus 105. And then, so we combine like terms. So I'm going to subtract 10x from both sides. And then add 105 on both sides of the equation. So that gives us 135 is equal to 25x. Therefore, x is equal to 135 divided by 25. And that is approximately 5.4 kilometers per hour. And this is the speed or the rate of the boat. Remember, that is what the question is asking me. It's the speed of the boat without any current involved. So in this case, we're looking at the speed of the boat in still water. That brings us to the end of the question. So the answer to the problem is 5.4 kilometers per hour. The next one says, so we'll change this to say Alfred. Alfred and Monica leave school traveling in opposite directions. Alfred is walking and Monica is biking. And as Monica is biking, she's averaging 6 kilometers per hour more than Alfred. If they are 18 kilometers apart after 1.5 hours, what is the rate of each student? How fast is each student moving? In other words, how fast is Alfred walking and how fast is Monica biking? So let's let x to be the speed of Alfred, or the rate of Alfred's walk. So that means Monica is biking at the rate of x plus 6. Remember, we are told that Monica is biking at the rate of 6 kilometers per hour more than Alfred. So we can now replace x, and this is x plus 6, where x plus 6 is the rate of Monica's biking. They both are moving at these speeds, and they covered the distances in 1.5 hours. Because we're looking at the distance 18 kilometers, which separates them after 1.5 hours. So after 1.5 hours, we examine the distance between them. and it happens to be 18 kilometers. So since we already know that rate times time is equal to distance, so we can multiply, and we get 1.5x, multiply x plus 6 times 125, so we get 125 times x plus 6. So this should be step 1. Filling the table should be step 2. In step 3 is to acknowledge that the distance, assuming this is the school, so Alfred moves in this direction and covers a distance of 1.5x. So this is assuming he stops at point A. Monica bikes and goes in this direction, and so covers a distance of 1.5 times x plus 6. And this is at point B. So the total distance between the two students is 18 kilometers. So that's the distance separating them. So therefore, 1.5 x plus 1.5 times x plus 6 should be equal to 18 kilometers. So we distribute 1.5 in the second term. So we have 1.5x plus, we look at this expression, so we get 1.5x plus 9 is equal to 18. So we get 3x plus 9 is equal to 18. And so 3x is equal to 9. And so x is 3. And so this is the speed of Alfred. So we can say Alfred's speed, rate of Alfred's walk is 3 kilometers per hour. And for Monica is 3 plus 6, which gives us 9 kilometers per hour. And that brings us to the end of this question, because the actual question was, what is the rate of each student? The problem about rate, time, and distance can be extended to problems involving amount of work done, rate of work done, and time. So whenever we think about rate of work done, we think of one job being done. So if one job can be completed in t units of time, then the rate of work is the one job divided by time, so that we have job per unit time. So for example, James completes a job in 8 hours. What is his hourly rate of job completion? So the solution to this is the rate is equal to 1 divided by time. So this is 1 divided by 8. So he completes 1/8 of the job in 8 hours. So job per hour. So part of the job that is completed in 1 hour is 1/8. And that is how you think about this. So let's extend this to another problem. AJ and Omar operate rooftop roofing company. AJ can roof a house alone in 9 hours. Omar can roof a house alone in 8 hours. How long will it take them to do the job if they complete this job together? So just identify. So in step 1, we will say, well, I use Simon in this case. So I guess I was thinking about myself. So let me use Omar as the problem states. So the rate of Omar's completion, so Omar's rate is 1 divided by 8, 1/8 job per hour. So that's the rate of completion by Omar. And then AJ's rate is 1/9. So he completes 1/9 of the job each hour, so per hour. So we can say for Omar, it's 1/8. For AJ, it's 1/9. So that's the rate at which they do this particular roofing. Well, and then, so our goal then, it says how long will it take them to do the job together? So we don't know, but they will do it together for the duration. So let X be how long it will take this job to be done. So we will say X is equal to the length of time taken to complete the job. So that means Omar will complete 1/8 of X. So let's call this DJ to mean the amount of job done by Omar. And then the amount job done by AJ will be 1/9 of X. So so that's step 2. In step 3, we will say the total job done is 1/8 of X plus 1/9 of X should be equal to 1, where 1 means the entire job has been completed. So if we solve this, we're going to look for the LCD. So the LCD is 72, and that gives us 9X plus 8X, and that should be equal to 1. So in other words, I'm multiplying this by 9 and this by 8, so that I end up with the LCD and then continue solving the equation. So 1, I will regard this as 1/1. So that gives me 17x divided by 72 is equal to 1. And so this implies 17x is equal to 72 by cross multiplication. And so x is equal to, so we divide 72 by 17. And so it takes both of these two guys 4.24 hours. So that's how long it will take both of them to do the work. And that brings us to the end of this presentation. I hope it helps. Thank you.